Ever wondered why the night sky sometimes puts on a mesmerizing light show? The aurora, also known as the northern or southern lights, is a natural wonder that can transform the heavens into a canvas of ever-changing shapes and colors. But here's where it gets fascinating. These displays aren't just random flashes of light, they come in distinct forms, each telling a story about the Earth's magnetic field and the solar particles interacting with our atmosphere. Let's dive into the most captivating shapes you might encounter, and, trust me, this is the part most people miss. Diffuse glows, the subtle prelude. Imagine a faint, hazy light hovering on the horizon, so subtle it could easily be mistaken for city lights. This is the diffuse glow, often the most overlooked yet common form of aurora. It's the quiet introvert of the aurora world, appearing when geomagnetic activity is low or during the beginning or end of a storm. Your camera will capture it long before your eyes adjust, revealing a soft, cloud-like illumination without defined edges. This happens because energetic electrons scatter widely before colliding with atmospheric particles, creating a uniform glow rather than sharp patterns. Arcs, the sky's brushstrokes. Next up are arcs, the aurora's way of painting the sky with curves or streaks. These can appear as smooth, homogeneous curves or as rayed arcs, resembling upward brushstrokes. Sometimes, they pulsate and flicker like ribbons dancing in the wind. Arcs form when charged particles flow along magnetic field lines, creating a concentrated band of light within the auroral oval, a ring-shaped zone around the Earth's magnetic poles. Rays, the sky's vertical drama. When the aurora amps up its game, rays steal the show. These vertical streaks shoot upward, either as solitary beams or as a sky full of radiant columns. They can even converge overhead to form a breathtaking auroral corona. Rays occur when particles follow individual magnetic field lines, producing parallel shafts of light that pierce the darkness. Curtains and draperies, the photogenic wonders. If arcs are the aurora's brushstrokes, curtains and draperies are its masterpieces. These forms resemble billowing sheets or shimmering veils, often rippling with a 3D effect. Essentially, they're arcs bunched up in parallel lines, aligned with magnetic field lines. But there's more to it. Currents and wave-particle interactions play a role in shaping these stunning displays. And this is the part most people miss. Scientists are still unraveling the mysteries of how these shapes form, making it a hot topic in aurora research. Spirals and swirls, the storm's signature. During intense geomagnetic storms or near the poles, the aurora can twist into spirals and swirls. These dynamic shapes reveal the turbulent, shearing motions within solar plasma as it's guided by Earth's magnetic field. It's like watching the solar wind dance in slow motion, a rare sight reserved for the luckiest skywatchers. Auroral corona, the overhead spectacle. Now, imagine the aurora dipping so far south or north that it fills your entire sky, beaming down as if touching the Earth. This is the auroral corona, a once-in-a-lifetime sight for many. If you've witnessed this, consider yourself among the privileged few. But here's where it gets controversial. While some forms like diffuse glows are common, others, like spirals or coronas, are rare and often tied to powerful geomagnetic storms. Does this mean we're missing out on understanding the full complexity of auroras? And could human-induced changes to Earth's magnetic field or atmosphere alter these displays in the future? Let's discuss in the comments. What's your take on the aurora's ever-evolving shapes? Bottom line, from subtle glows to dramatic coronas, each auroral form is a window into the intricate dance between the sun and Earth. So, the next time you gaze up at the night sky, you'll know exactly what stories those lights are telling.